Hi friends, after looking into the circuit which allows only lower frequencies to pass on but does not allow high frequencies to pass on is the one which we call low pass filter. Here the one lower frequencies which it passes is a band of frequencies called passback, whereas the band of frequencies which we will not allow is called stop band. And that's one way of working with it. The other way of looking at the same system is instead of looking at this level of water in this tank as the output, you just try to see the difference between these two levels as the output. So if you concentrate on difference between these two, then what would happen? So under equilibrium, the two levels are equal, so the difference is zero. Now, if this is made to change very slowly so that the system can follow it, then this will also keep changing along with this, and hence the difference will be zero. If you make changes very fast here, then system cannot cope up with that fast change. Therefore, this level will not be able to follow up. Therefore, we start seeing the difference between these two levels. So that's a other way of looking at the same system. Now what we did is earlier we have looked at um, water level at the tank, output tank. Now we are looking at water difference in water levels of the two tanks. That means the differential potential energy across the two tanks. That means difference in potential energy across this pipe, that is the resistance which is creating. So it's something looks like this. Now the capacitor comes in series, whereas the resistance comes in shunt as opposed to this one. So when we have some voltage V, then under steady state condition this may also reach V. So V minus V, we get a output voltage across R equal to 0. If this is made to change very slowly, the capacitor will get sufficient time to follow the changes, and hence this output keeps remaining 0. But if the speed with which the change is done with this, if it is increased, that is the frequency of changes increased, then the R will not allow sufficient current to flow, and C will not be happy with the little current to find its change across. Therefore, this will be unable to follow this. As the frequency of this increases, this will not be able to follow it, and hence this you can start feeling the difference. So for lower frequencies, there won't be any output. As the frequency increases, then this cannot follow up. Therefore, this starts to show uh, its output across R. So, if you want to talk in terms of frequency response, then it's something after some value you find that everything is visible across this, but below that, yes, there is something which it cannot allow. So there is a something called stop band here, and there is pass band here, and this type of circuit is called a high pass filter. So the earlier one, this one allows only lower frequencies, so we call low pass filter. This allows only high frequencies, therefore this is called high pass filter. So these are very much useful in our future circuitry, where some uh, band of frequencies we need to allow. If you want low frequencies to be allowed, use low pass action. You want only high frequencies, then use high pass action. And there are two more filters. We look into them in detail in the coming lectures. The same action can be seen using RL circuit also, and that's what will be the matter to be discussed in our next section. So, till then, take care. Bye.